Question number 2. What is question number 2? The probability density function of a Gaussian distribution is 1 divided by 3 root 2 pi into e power minus of x minus 4 whole square by 18. Now what he is asking is the probability of the event. The probability of the event x equal to 4 is dash. Okay. So this is the question. So we have a relation between probability and probability density function. What is the relation between probability and probability density function? Which is equal to integral minus infinity to x f of x dx. So you can take x 4 here, therefore 4, and you can get some answer. Okay. Now which is a wrong analysis. See, if you have this particular thing, what he is asking, this is a Gaussian probability density function. This is the Gaussian probability density function. The Gaussian probability density function or a Gaussian distribution which is a continuous distribution. Which is the continuous distribution. For continuous distribution, you are asking probability at a single point. For continuous distribution, probability at a single point is not possible. Is not possible. If the probability is not possible, what is the answer? The answer is 0. The relation, sir, there is a relation between probability and probability density function. Yes, there is a relation between probability and probability density function for continuous. If the question is like this, then the answer is available. But what he is asking probability at a single point is not possible. This is a continuous distribution minus infinity to 4 fx of x dx. This is valid, but he is asking only at x equal to 4, not possible. If the probability is not possible, if event is not possible, then the probability is 0. This is not possible or 0. Because Gaussian distribution, which is a continuous distribution, for continuous distribution, the probability calculation at a single point is not possible. It is undefined, and a not possible event is not possible means answer is 0 or not possible to find a probability for a continuous distribution at a single point. Understand or not? No doubt. For better understanding, I give you one more question. Now question number 3 is, by considering the following probability density function, curve, he is asking to determine the probability of x less than or equal to 1. By considering this function, he is asking find the probability of x less than 1. See this case and previous case. Previous case is asking only at a single point, but this case is asking to find the probability of a random variable x for all the values from minus infinity to 1. So then there is a relation. There is a relation between probability and probability density function which is nothing but integral minus infinity to x f of x dx. So therefore, probability of a random variable x, which is equal to integral minus infinity to 1 f of x dx. So which is nothing but integration is nothing but area. The integration is nothing but area. Now the area up to 1 minus infinity to 1. So this is the area you want to calculate it. So this is nothing but one triangle or not? What is the area? Half into base into height. Now which is nothing but half into, what is base? Base is 3 into height. What is height? 0.25, which is nothing but 3 by 8, 4 into 2. This is the continuous distribution. There you can find the continuous values. But for a continuous distributions, you cannot find at a discontinued point. Is not possible. Question number 4. A random variable x is uniformly distributed. A random variable x is uniformly distributed in the interval 0 to 1. A random variable x is uniformly distributed in the interval 0 to 1. If a random variable x is uniformly distributed in the interval a to b, which is nothing but 1 by b minus a, is a uniform probability density function 1 by 1 minus 0, which is equal to 1. So this is a random variable x is uniformly distributed in the interval 0 to 1, means this is not given in the question. You have to be identify this, you know that, okay? If a random variable x is uniformly distributed in the interval 0 to 1 and this is the probability density function, then what he is asking? He is asking a random variable x is quantized as follows. A random variable x is quantized as follows. xq equal to 0 for 0 less than or equal to x less than or equal to 0.3 and xq equal to 0.7 for 0.3 less than or equal to x less than or equal to 1. xq is quantized value of x. xq is the quantized value of x. Then he is asking to find root mean square value. Now, first we will find the variance. What is the variance? Expectation of the second central movement. The second central movement of a random variable x is called as variance. Now this is the second central movement of a random variable x is called as variance. But in the question is given xq is the quantized value of x. Therefore, now instead of mean, then you can take this is the quantization value, because the quantization level, the successive difference between the quantization levels is called as step size, middle of that. So average of that. So I can take xq square. So which is nothing but integral minus infinity to infinity x minus xq square and fx of x dx, which is integral 0 to 0.3 x minus xq is 0 whole square fx of x is 1 dx plus 0.3 to 1 x minus xq is 0.7 whole square fx of x is 1 dx. Now this is the variance. This is the variance. Now the standard deviation or root mean square value, the standard deviation or root mean square value, which is nothing but square root of variance. Okay. Now question number 5. A symmetrical 3-level quantizer A symmetrical 3-level quantizer is to be designed equiprobable occurrence as follows. See here, this is the quantizer whose probability density function is given like this. This is region 1, this is region 2, and this is region 3. Now this is divided into 3 regions like this. Right? Now this is region 1, region 2, region 3. What he is saying is, now a 3-level quantizer is to be assumed equiprobable occurrence in all the 3 regions. Therefore, the random variable x may be in a region 1, maybe in a region 2, maybe in a region 3 of probability equiprobable. Means what is that? The probability of a random variable lies in region 1 and a probability of a random variable lies in region 2 and a probability of a random variable lies in region 3, which is equiprobable. which is equiprobable, 3 regions, equiprobable occurrence is 1 by 3, 1 by 3, 1 by 3. So the random variable x lies between -3 to -1, and a random variable x lies between -a2 plus a, and a random variable x lies between plus a2 plus 3. So in each region the random variable may have a chance of equiprobable. So what he is asking is finally find the value of a as shown in the figure. So where there is a in that particular region, then you find the a value, and he is also asking find the power in the region of a. So what should we do? First we will sign. So the probability of a random variable x lies between -a2 plus a. There is a relation between probability and probability density function, which is nothing but integral -a2 plus a fx of x dx, which is nothing but integral -a2 plus a. In the region -a2 plus a, what is the probability density function? Which is 1 by 4 dx. Therefore, which is nothing but 1 by 4 dx is x in the region of -a2 plus a. So which is nothing but a minus of minus a, 2a by 4, right? So what is the probability of a random variable x in the region -a to a? Now here is given a probability. Now what is the probability if a region 2, which is equiprobable, right? So the probability of a random variable in any 3 regions are equiprobable. Therefore this is 1 by 3, which is equal to 2a by 4. Therefore which is nothing but a, which is equal to 2 by 3. A, which is equal to 2 by 3. And in the same question, what he is asking is determine power in the region A. Means this is region 2. So power, which is this is the quantization noise power or any power, which is expectation of x square, mean square value is the power is nothing but integral -infinity to infinity x square f of x dx. So which is nothing but integral -a to plus a region he is asking power, fx of x is 1 by 4 into x square dx. Therefore power, which is equal to 1 by 4 x square is x cube by 3 over the limits -a2 plus a. Therefore power, which is equal to 1 by 4 into 3, now a cube minus of minus a cube, which is equal to 2a cube by 4 into 3, which is equal to 2 by 4 into 3. What is a? A is 2 by 3, 2 cube 8, 3 cube 27. So therefore the answer is 4 by 81 is the power in the region A. Now question number 6 is, now what is the question number 6? Question number 6 is a signal x of t, which is equal to AC cos 2 pi fct plus phi, where phi is a random variable, where phi is a random variable is uniformly distributed, in the interval where phi is uniformly distributed in the interval 0 to 2 pi. So uniform distribution function is nothing but fx of phi, which is 1 by 2 pi minus 0, which is equal to 1 by 2 pi. Then what he is asking is, he is asking to find the autocorrelation function. What is the autocorrelation function? The autocorrelation function, which is nothing but integral minus infinity to infinity x of t plus tau d tau. Sorry, fx of phi d phi, which is equal to integral 0 to 2 pi fx of phi, which is equal to 1 phi. What is x of t, which is ac cos 2 pi fct plus phi, and x of t plus tau ac cos 2 pi fct plus 2 pi fc tau plus phi into d phi. So which is nothing but AC into AC square by 2 phi. If you take a 2 cos A cos B, if I multiplied and divided with 2 cos A cos B, which is nothing but 0 to 2 pi cos of A plus B cos 4 pi fct plus 2 pi fc tau plus 2 phi d phi plus cos of A minus B 0 to 2 pi fct cancel, phi cancel, so cos 2 pi fc tau d phi. Now over a period of time, then this value is 0. Therefore, which is nothing but AC square by 2 phi into 2 cos 2 pi fc tau is constant 0 to 2 pi over a period of d phi. Now this value is nothing but 2 phi minus 0, 2 phi. This 2 phi cancel. Therefore, autocorrelation function, which is nothing but AC square by 2 into cos 2 pi fc tau. This is the autocorrelation function. Now here you can easily find, you know that autocorrelation function at origin, which is equal to, see here, AC square by 2, tau equal to 0, cos 0, 1. So what is this? Autocorrelation function at origin, which is nothing but, then you have one long relationship between autocorrelation function, power spectral density, all these things. Autocorrelation function at origin, which is nothing but energy of the signal, which is nothing but area under power spectral density, is nothing but power. What is the power of this signal? The power of this signal is nothing but, this is the sinusoidal signal, peak amplitude divided by root 2, RMS value, Vrms square by R is power. So AC square by 2R, R equal to normalized 1, AC square by 2R. You are getting the same answer or not? So autocorrelation function at origin, which is nothing but area under power spectral density, or which is nothing but power of the given signal, will be matching or not? No. Question number 7. Now the probability density function is given. He said which is uniformly distributed in the interval a to b. So you can easily find this is the probability density function. Now he is asking statistical averages for this particular signal. What is the statistical averages? Which is nothing but mean, which is integral minus a2 minus infinity to infinity x fx of x dx, which is equal to integral a to b 1 by b minus a x dx, which is nothing but 1 by b minus a integration of x dx is x square by 2 over the limits a to b. Therefore, b square minus a square by 2 into b minus a. Therefore, b plus a by 2. This is the mean of a random variable x. And similarly, mean square of a random variable, integral a to b x square f of x dx, which is equal to 1 by b minus a integration x square dx over the limits a to b, which is nothing but x cube by 3 over the limits a to b into b minus a. Therefore, b cube minus a cube by 3 into b minus a is the mean square value. And you can easily find variance, which is equal to mean square value minus square of the mean. This is a mean. You can have. This is the statistical averages.